On this 2010 through 2016 Honda CR-V with the 2.4 gas engine, P0843 points us toward the CVT-driven pulley pressure sensor/switcher circuit. In plain terms, the ECM/PCM may be seeing a high signal condition from that sensor circuit. The vehicle may show a transmission warning. CVT operation may feel different or limited, and the concern can be intermittent if the signal or connection changes with conditions. For this code, stay focused on the electrical side. Possible connector or terminal issues, wiring in the sensor signal, power, or ground-related circuits, the CVT-driven pulley pressure sensor circuit, and only after the circuit checks pass, possible PCM software or PCM concerns. This path is not chasing a mechanical failure inside the transmission. Start with the basic system checks, then work the circuit in order. First, verify the problem. Turn the vehicle to the on mode, clear the DTC with the HDS, and watch the driven pulley pressure sensor, V parameter. For this code path, the key check is whether that parameter is more than 484 V. If the failure duplicates, keep going into the circuit isolation test. If it does not duplicate, treat it as intermittent for now. The system is okay at this time, so check for poor connections or loose terminals between the CVT-driven pulley pressure sensor and the PCM. If captured data is available for this DTC, try to reproduce the same operating conditions instead of guessing. Next, turn the vehicle to the OFF lock mode and disconnect the CVT-driven pulley pressure sensor 3P connector. Install a jumper wire between terminal A and terminal B. Terminal A is connector no. 1 and terminal B is connector no. 2. Turn the vehicle back to the on mode and check the driven pulley pressure sensor V parameter again. The decision point is the same, more than 484 V. If it still reads high, move to the PDN line open check. If it does not, move to the sensor side voltage checks. If the jumper test keeps the signal high, turn the vehicle to the OFF lock mode and remove the jumper wire. Jump the SCS line with the HDS and wait more than 1 minute. Then disconnect PCM connector C, the 51P connector. With the vehicle still OFF lock, the sensor connector disconnected, and PCM connector C disconnected, check continuity between the CVT-driven pulley pressure sensor 3P connector no. 2 and PCM connector C, 51P no. 49. If continuity is present, the PDN wire is okay. At that point, update the PCM if it does not have the latest software, or substitute a known good PCM and recheck. If P0843 goes away after the update, troubleshooting is complete. If it goes away with the known good PCM substituted, replace the original PCM. If there is no continuity, repair the open in the PDN wire between the CVT-driven pulley pressure sensor and the PCM. If the jumper test did not keep the signal high, turn the vehicle to the OFF lock mode, remove the jumper wire, then turn the vehicle to the on mode. With the CVT-driven pulley pressure sensor 3P connector still disconnected, measure voltage between connector no. 1 and connector no. 3. You are looking for about 5 V. If about 5 V is present, replace the CVT-driven pulley pressure sensor. If about 5 V is not present, continue to the power supply circuit check. For the last circuit split, keep the vehicle in on mode with the sensor 3P connector disconnected. Measure voltage between connector no. 3 and body ground. Again, the question is whether there is about 5 V. If about 5 V is present there, repair and open in the SG2 wire between the CVT-driven pulley pressure sensor and the PCM. If about 5 V is not present, repair and open in the VCC2 wire between the CVT-driven pulley pressure sensor and the PCM. After the repair decision is made, keep verification separate from the circuit testing. Clear the DTC, run the vehicle under the conditions needed to check the monitor, and make sure P0843 does not return. The takeaway is simple. P0843 is an electrical diagnosis. Confirm the high sensor voltage, split the circuit with the jumper test, then follow the result through the PDN, sensor, SG2, and VCC2 checks in order. For more diagnostic training, visit stepdiagnostics.com.